So we are going to start from the next one. We'll continue from the next one. Next one is isothermal. We hear isothermal process. In this case, you know that your temperature, because thermal is talking about heat. So in this case, we talk about temperature, that the temperature remains constant. So the work done. And remember, whenever this thing, it must come out in your exam. It must come out in your exam. This tutorial, this 6 momentum science screen tutorial, is a tutorial that will give you a guidelines, a hint, solid things or short things of what you must surely see in your exam, according to the professor, scientist T. Ebebe. You must surely see it. Please take note. You must surely see it in your exam. Please take note. But the reason of this, I want to give you a hint, this thing, a secret. Now, whenever you see this delta T, this triangle, whenever this triangle is not available, then this triangle is called changes, either an incremental change or a decremental change. Are with me? So it is also called infinitesimal. So this infinitesimal change in temperature denotes two entities, Celsius and what? Kelvin. Celsius and what? Kelvin. Listen, whenever this triangle is attached to this thing, it indicates two things. Listen, it is a hint. You won't see it in exam. It indicates two things, and those two things are Celsius and what? Kelvin. Whenever this triangle is attached to this temperature, it means that the temperature is either in what? Can either be in what? Celsius or what? In Kelvin. Means your final answer can mean either in what? Celsius or in what? Kelvin. And you know, Celsius is a scientific father of 6 momentum. His name is called Celsius. The name Celsius was formerly called centigrade, but it was changed to Celsius, and the man called Celsius, born on 1704. Is what? An Swedish astronomer. It's called what? He's a Swedish what? Astronomer. A Swedish astronomer. He's born in Switzerland. A Swedish what? Astronomer. So Kelvin, his name is also called Lord Kelvin. A scientific father of 6 momentum, Lord Kelvin, William Thomson. Another name is also called William Thomson, born in 1824 and died in 1907. He's a British physicist, a British physicist, who became a professor in philosophy at Glasgow University. Take note of all these things. So whenever you see this delta attached to this temperature, it means there is Celsius or what? Kelvin. But whenever this data is not attached, always take note it's only on what? Celsius. Please take note. It's only on what? Celsius. So in this case, there's no time, please, I need to go for. So in this case now, your work done is equals to Q. Your work done is equals to what? Q. Your work done is equals to what? Q. Your work done is equals to what? Work done is equals to Q, meaning that the work done on this system. Remember my theory. I said that universe is equivalent to system plus surrounding. It means that there's a mathematization of a system and its surrounding will give you what? The universe. So the work done is equals to what? The heat flow. It's equals to the heat flow. So we have that your heat flow. Okay, let's continue with the work done. So we have that the work done can also be given as W equals to N RT natural logarithm. Let's say N RT or N delta T natural logarithm volume, the final one, and the volume of the initial. Then we'll go to the next one on. There's no time, we'll go to the next one on. We'll go to the next one on internal energy of the isothermal process, the internal energy of this isothermal process. Sorry for my marker. Internal energy of this isothermal process will be given as delta U. Okay, let's go for internal energy. Let's do the heat flow first. So the heat flow of this isothermal process will give us Q is equals to, okay, let's say Q is also equals to W, because as W is equals to Q, so Q is equals to W. If I call this equation 14, I call this 15, I call this 16. I'll call it because 16 is something, okay, 16, let's call it 17. Let's call 17. Then I'll still give it that my Q is still set as say Q N arrow delta T or T, depending on the question, final pressure over the initial pressure. Final pressure over the initial pressure, the logarithm, the natural logarithm, final pressure over the initial what? Pressure. Yes, so let's go on the internal energy. The internal energy, if you recall, delta U, the interrelated delta U is given as NCV delta T. But in this case, your temperature is 0, so you have that your delta U is equals to NCV bracket 0. So you have your delta U is equals to NCV. So equation 18, equation 19, equation. Okay, this is something important. Yes, call this equation 19. Suppose equation 19. Go to equation 19. So the next one, okay, I want to show you something. Now, I've told you that isochoric is on Gay-Lussac's law, isobaric on Charles' law, that is Jacques Charles, Joseph Gay-Lussac, and this is called Robert Boyle. Robert Boyle, a Danish physicist, he's called a naturalist, mathematical principal philosopher. He has his own book. He was the first one that brought about the philosophy mathematical book. Robert Boyle was the one that invented the J-tube instrument using to detect the flow of gases. I will not go more details on it. But we are going to go on. Now I want to show you that constant temperature means that what is the entities involved is pressure and volume. So when pressure increases, the volume also what increases. So we have that P1 V1 is equals to P2 V2. And this isothermal process, in this case, we know that the heat or the mass of that surrounding is what constant. We have a PV diagram. That's in our next class when we're talking about first law of thermodynamics. We'll talk about the PV diagram. First law of thermodynamics. But in this one, now this isothermal is okay. Let me ask you a question. Now listen. Now in Boyle's law in gases, whereby we say that at a constant temperature, the pressure of a given mass of a gas is directly is inversely proportional. The pressure of a given mass of a gas is inversely proportional to the volume of that gas, of that same gas. To the volume of that same gas means that P is inversely proportional to 1 over V. P is inversely proportional to 1 over V, which implies that P is equals to, I can call it omicron. This is called omicron. I call it Dirac. This will call my Dirac over V. I call it as the proportionality constant. Dirac over V. So this is, that's how we got this. So this isothermal is used to show the relationship between pressure and volume. So call this equation 20. So the next one is adiabatic process. The adiabatic process adiabatic process. Now the adiabatic process is given. Now in this case, the adiabatic process, this is whereby there is no heat or mass flowing in that surrounding. Sorry, nobody's getting me. There is no heat or mass flowing in that what surrounding. Heat does not flow into or outside in that surrounding. Take note. That is simple. I will not speak any grammatical name, or I will not give a grammatical name. I will not speak any scientific term. I will just give you a clear language you need to understand. There is no what heat flowing in and out of that what surrounding. Take note. Now listen. The work done of this adiabatic process, the work done. Oh, this is my marker. The work done of this adiabatic process. Please, sorry. The work done of this adiabatic process is given as NCV theta T. Some people ask, how is this possible? You remember that your Q is equals to, if you recall, your Q is equals to W, and your Q is NCV theta T. So therefore your W is NCV or theta T. But it's only this on what adiabatic was process. Just knows the formula. So we have that the CV, which is the molar, this is my markers. The CV, which is the molar heat capacity of an ideal gas of a constant volume, is given as 3/2R, while the Cp, that is the molar heat capacity. This R is called molar gas constant. It's given as 5/2R. If I'm correct, if I'm right, shake, I don't know, not sure, please help me research more. A teacher cannot be perfect, a teacher can never be perfect. Help me research more, please. And your Q, the heat flow, listen, the heat flow is equal to 0. Why? Because no heat flows in the surrounding, so it's equal to what? 0. No heat flows in or out of the surrounding, so it's equal to what? 0. It's minute. It's even like this. The theoretic or accumulative degree is equal to what? 0. When internal energy that U, internal energy is equal to delta U is given as delta U equals to Q minus W, where Q is equals to 0, where Q is equals to 0. So I have calculate this equation 21, this is equation 22, equation 23, and this is equation. This is equation, forget 24, and delta U equals to Q. Yeah, no, because Q is equals to 0 is equals to minus W, equation 25. We'll stop here for today. We'll stop here for now. We'll come back later. Please study it carefully, strategically. Please study it. If you have any question, drop your question in the tutorial group. On behalf of the professor, Scientist Ebebe, who is absent of today's tutorial, we plead that you should pardon him. Please, if you have any question, drop your question in the tutorial group. Drop your question. Now, thermodynamics is different in physics and it's also different in chemistry. The formula you see in thermodynamics, this is the first. Let's assume. Don't worry, I will teach you more. Don't worry. First law of thermodynamics will be very interesting. So today is our first video tutorial we are doing. So please, I know it's not organized, but please pardon us, please. Thank you. May God bless you. Goodbye.